we're still in kinematics chapter, and today we will talk about speed and velocity. We discussed before how to find the displacement and the position of an object, either in a one-directional linear displacement or in two-directional displacement. Today we'll talk about speed and velocity and what is the difference between speed and velocity, and being able to find the equation behind the speed and velocity of the object. So firstly, we start with velocity. So if we imagine again a golf ball, so golf ball at 0 seconds was at location 0 meters. After 1 second, the golf ball moved for 1 meter. After 2 seconds, it moved for 2 meters. After 3 seconds, it moved for 3 meters. 4 seconds, 4 meters. 5 seconds, the ball was 5 meters away from the origin point. We can see the golf ball is making a displacement from point 1 to point 2 to point 3 to point 4 to point 5 and to point 6. So of course we learned the tools and the equations needed to find the displacement of the golf ball between each one of those positions. So we can easily find the displacement, which is important in defining velocity. And let's say we have a stopwatch and we were detecting when the ball was at 1 meter, it was at 1 second, when it was at 2 meter, 3 meter, and so on. So you are trying to study the displacement of the ball with respect to time. So the ball obviously is being kicked and it is moving to the right direction in this case. So in this case we have a motion. So in displacement we have the object in position 1, then we study the object in position 2 and find the displacement based on those two locations. Now when the object is moving with respect to time, that's what we call velocity or speed. Now if we take the golf ball motion and put it in a table to be able to look at what is going on with the golf ball, that would help us to define the velocity equation. So let's keep in mind that the velocity is the change in position with respect to the change in time. So we know all the positions of the golf ball. So we know it was at 0 meters, then 1 meter, 2 meters, 3, 4, and 5 meters. Now we had a stop timer that is detecting when the ball was at 0 meters, when the ball was at 1 meter, 2 meters, 3 meters, 4 meters, and 5 meters. And we called those T0, which is the time at location 0, T1 time at location 1, location 2, 3, 4, and 5. So we have the position of the ball and the time when the ball was at that position. And that is all what you need to define velocity. So velocity, change in position, as we said, divided by change in time. If I want to see what is the velocity at position 1, change in position between 1 and 0 is 1 meters. Change in time between 0 and 1 seconds is 1. So that would be 1 over 1 would equal 1. And the units would be meters for the position per second. If that's not clear yet, no problem, stick with me and you will be able to understand exactly what is going on. So we're still confusing you between velocity and speed. And probably you heard that speed equals distance over time. So when we looked at the golf ball moving from distance 0 meters all the way to distance 5 meters, that is the distance the ball traveled over time. Let's say it took the ball 5 seconds to reach between 0 to 5 meters. So now we know the distance to be 5 and we know the time being 5 seconds. So 5 meters. We need to know something. There's a difference between speed and velocity. Velocity is a directional value and speed is a scalar value. What does that mean? It means the velocity, if I would say what is the velocity of that person who's running, I would say 15 miles per hour or 15 meters per second. And if I want to say what is the velocity of that person, I would say it is either 15 meters per second or minus 15 per second. It means velocity is taking care of the direction of the object, while the speed, it doesn't care about the direction. This is why we see this arrow over here pointing to the right. That means in mathematics, it means this value is directional, and we have the displacement, this value directional. Time, we don't see any arrow here because time is not a directional value. So it doesn't matter. Time is always moving forward, or time always positive value. Simpler term for velocity, we can say the difference in x over the difference in time. So the distance can be found x final minus x initial over the time t final minus t initial. So you can say here v equal delta x over delta t. Change in position or displacement on the horizontal line divided by the change in time for that exact object. So we can say the final position minus xi or xo, the initial position, over t final minus to, which is final time minus initial time. In case of the ball, again, moved from 0 meters at 0 seconds all the way, moved to 5 meters, and it had 5 seconds of time to reach that point. Now in this case, what is the velocity of that golf ball? It is x final. What's the final location? It was 5 meters minus x initial location was 0 over t final was 5 seconds. It took the ball 5 seconds to reach final location, minus what was the time at location 0? That was 0. That would give you 5 over 5 or 5 divided by 5, which gives you 1, and the units are meters divided by seconds, distance over time. So meters over second, or you say meters per second. Hopefully it's clear for you so far what's going on here. It could be confusing at first, but when you wrap your head around it, it should be no big deal. Now, as we mentioned, there is a velocity and there's a speed. So you can say speed is related to value. Let's say speed equal 15 meters. I don't know why this program keeps deleting stuff. 15 meters per second. But velocity for that same object would be either plus 15 meters per second, which means 15 meters per second to the right, or could equal minus 15 meters per second, which means, so this is to the right direction and this is to the left direction. So minus here doesn't mean the value, the mathematical value minus 15. It means the speed or the velocity is still 15 meters per second, but in the other direction or in the left direction. So now we have those two carts. One cart is moving to the right at a speed of 4 meters per second. Another cart is moving on another rail to the left, 4 meters per second to the left. Now, are we talking here about, can we represent this in terms of speed or in terms of velocity? Of course, in terms of velocity, because this would be v, in this case, equal plus 4 meters per second, while v here equals minus 4 meters per second, which means 4 meters per second to the left. So that's the difference between speed and velocity. Speed is a number that doesn't care about directions. It's an absolute number, while the velocity cares about the direction of the object. Now, if we want to know how to find the instantaneous velocity of a certain object, let's imagine this rally car. So over here, we have this car at position 0. As you can see, the car at position 0 meters, and the timer is saying 0 seconds. Timer is not set yet. The car start accelerating or start moving. Now, at 2 meters, that's where the car next location, the time was ticking at 1 second. At 8 meters, the time was ticking at 2 seconds. At 18 meters, the time was 3 seconds. Now, instantaneous velocity means finding the velocity at a certain moment. You know, objects are moving in a certain velocity, then you can find the speed or the velocity of that object by calculating, as we saw in the equation, the difference in distance over the difference in time. Then you can find the velocity, which we call it as, in many cases called as the average velocity. But if you need to know the instantaneous velocity, the velocity at certain time, let's say I want to know the velocity of this car at 8 meters. In this case, I can say the instantaneous velocity equals distance over time. As simple as that. What's the distance here? 8 meters over the time 2 seconds. That would be 8 over 2 is 4 meters per second. So, the instantaneous velocity for the car at 8 meters equals 4 meters per second. Okay, what is the instantaneous velocity of this car at 18 meters? That's distance 18 over time. At that moment, the time was 3. 18 over 3 equals 6 meters per second. And you can see here the instantaneous velocity or instantaneous speed differs at each moment you pick up, unless the speed of the vehicle is constant. In many cases, the speed of the object is constant. We know this car is moving 4 meters per second from the moment it hit 2 meters all the way to 18 meters. It's just driving on 4 meters per second. There's no increase or decrease in the velocity. In this case, the velocity is constant. The velocity will be the same wherever you measure it. But in this case, distance is changing and time is changing. Then the instantaneous velocity will be different from one location to another.